Hi, welcome to the lesson on multiplying a polynomial by a monomial. When we discuss the distributive property, we mean that we are going to be multiplying each term in a polynomial by a value that's outside a set of brackets. And the products of the inside will then be added together. So, for example, if we started out with 4 times 7 plus 8, the distributive property means that we're going to multiply 4 times 7 and 4 times 8. So there we go, 4 times 7 plus 4 times 8. 4 times 7 is 28. I'm not sure why it's over there. And 4 times 8 is 32, and then we add them together to get 60. Okay, we can also see this and refer to it as expansion. So we can expand a set of brackets, or use the distributive property and remove the brackets, which all means to multiply a polynomial by some term, or which is also called a factor. And usually, in this case, anyways in grade 9, we'll say that that factor is basically a monomial. So what we're going to do is distribute, and when we distribute by multiplying, by expanding, we then remove the brackets so that we can, if we need to, collect like terms quite easily. Okay, so the first example, we've got 3 times 2x plus 4. We're going to expand and simplify. So in this case, because there's no sign, no operational sign between the 3 and the bracket, we're going to do 3 times 2x and 3 times 4, and we're going to keep that sign. So that gives us 3 times 2x plus 3 times 4, which gives us 6x plus 12. Notice that these are not like terms because there is a variable x here with exponent 1, but there is no variable x here. So because there's no variable x in the second term, that means that those two cannot be added together. This actually has the same form as a y-intercept and a slope multiplied by the x term. So because the slope is the actual inclination of a line, as we've seen it as rise over run, and the y-intercept is just at one specific point, it does not make sense to add a point to something that is not a point, which is in this case the slope. Okay, so that stays as it is and cannot be simplified further. Moving over to example B, we're now going to multiply this term x, or this factor, which is also a monomial because it's just one term, and we're going to distribute that into 2x and multiply it by 1. When we multiply into a set of brackets like that, we remove the bracket, and we're going to use our power laws, also the exponent laws. When you multiply powers of the same base, here we got 2 x's, they both have the same base, and they both have the same exponent, and just coincidentally in this case, but when you multiply powers, you add the exponents and leave the base the same. So we multiply the coefficients together first, so here I'll just expand this first. We get x times 2x plus x times 1. The coefficient of this x would be 1. We multiply the two coefficients together, so we get 2. And we multiply x times x. Both of these x's are actually powers with exponent 1 that you don't see until I write it in there, of course. And so you multiply those two powers by adding the exponents and leaving the base the same, so we get x squared. And then here we just have x times 1, which gives us plus x. So now both of these terms have variables of x. This has an exponent of 2. This has an exponent of 1 that of course you don't see, because they are not, they are not like terms because they are not the exact same variable with the exact same exponent. They are the same variable, but they do not have the same exponent, so you cannot add them together. Okay, so that stays as it is, 2x squared plus x, because they're not like terms. Moving right along, example C, we've got 5p cubed times 2p squared minus p plus 1. Again, we're going to multiply this in, expand into the brackets, and we'll have 5p cubed times 2p squared plus 5p cubed times negative p plus 5p cubed times positive 1. We'll multiply the two coefficients together to get 10. We multiply the two powers together by adding the exponents and leaving the base the same. Here we're going to multiply the coefficients together. Here the coefficient is 5. Here the coefficient is negative 1. So we multiply the two coefficients together, so we get positive 5 times negative 1, which leaves us with negative 5. And then p cubed times p to the exponent 1. Multiply the two powers together, they have the same base. Add the exponents, leave the base the same, p to the power 4. And then 5p cubed times 1 is just 5p cubed. Now examine all the terms. We've got 10p to the power 5, negative 5p to the power 4, and positive 5p cubed. They all have the same variable, but all the exponents are different. So because each of these terms does not have the same variable with exactly the same exponent, these are not like terms. So we cannot combine these any further, we cannot simplify it any further, because they're all different terms. Okay, so this stays exactly as it is with no further simplification. We'll move along here. Negative 2x times x squared minus 4x plus 5 plus 3. When we expand in a set of brackets, when we reach the end of the bracket, we stop. Okay? We do not go any further. That signifies the little stop sign. If you can see that as a stop sign, I'll actually write the word stop right on it to improve my diagram. So we expand in the brackets and stop. That 3 does not get expanded with the negative 2x. And then now we just expand in, we multiply coefficient times coefficient. Negative 2 times 1 is negative 2. Then x times x squared, that's x to the power 1 times x squared. We add the exponents, leave the base the same. X cubed. Then we do negative 2 times negative 4. Two negatives multiplied together give you a positive. X times x. Both of these have the exponent 1. So you add the exponents, leave the base the same. Then negative 2x times positive 5. Negative 2 times 5 is negative 10. X. We do not expand this to the negative 2x with a 3 because that's the 3 is outside the brackets, so we just add 3. Now we look at all these terms. Base of x, base of x, base of x, that's great. However, exponent of 3, exponent of 2, exponent of 1, these are not like terms because they do not have the exact same variable with the exact same exponent. And this does not have a variable at all. So none of these terms are like terms, therefore they cannot be added together. Let's move along to something a little bit more challenging.